Okay, we're going to be continuing our work now, preparing for the CUNY assessment test. This is the second tape in our series of videotapes. The first thing we're going to do on this tape is to prepare for a question. We usually have a question involving adding or subtracting various units of time or weight or length. And in order to prepare for this, we have to remember a few basic facts. For units of time, 1 hour equals 60 minutes. 1 minute equals 60 seconds. There's 60 minutes in an hour, 60 seconds in a minute. Okay, you'll need that for our work with time. For weight, basically all you'll need to know is that 1 pound is equivalent to 16 ounces. And for length, 1 foot is equal to 12 inches. Okay. From the previous CUNY assessment test, these are basically the facts that you must know in order to be able to do the problems. Okay, let's see the kinds of problems you might get. Well, you might get an example like this. Add 2 hours, 45 minutes to 3 hours, 22 minutes. Okay, and similar to our work when we were adding integers, we would start over on the right, so we're going to start with the minutes. So we add 45 plus 22. 5 plus 2, that's 7. 4 plus 2, 6. 67 minutes. 2 plus 3, 5 hours. However, this being a multiple choice question, don't be surprised if 5 hours, 67 minutes does not appear as one of the possible answers. That's because we can actually change 67 minutes. We can think of 67 minutes as being equal to 60 minutes plus 7 minutes. And 60 minutes is, of course, 1 hour. So 1 hour plus 7 minutes, or 1 hour, 7 minutes. 67 minutes can be rewritten as 1 hour, 7 minutes. So we can cross off the 67 minutes and write it as 1 hour, 7 minutes. And then continue this and add this, so we have 6 hours, 7 minutes. Okay, 5 hours, 67 minutes is not incorrect. However, it's probably not going to be one of the choices on the exam. We rewrite 67 minutes as 1 hour plus 7 minutes, add that. In other words, this is 5 hours, 67 minutes means 5 hours plus 67 minutes, and we rewrote the 67 minutes as 1 hour, 7 minutes, added it to the 5 hours, we got 6 hours, 7 minutes, and that would probably be the answer that you would see on the test. Okay, as our next example, let's try this. 7 minutes and 10 seconds take away 3 minutes, 47 seconds. Okay, just like in the subtraction that we learned in the last tape, we try to subtract 47 from 10, but we can't do that because we don't have enough there. This number has to be larger. So we're going to borrow from the minutes column. Instead of 7 minutes, I'm going to rewrite this as 6 minutes, and I have an extra minute, but that extra minute I'm going to write as 60 seconds. So I have borrowed from the minutes column 1 minute, which I translated into 60 seconds. So we now have 60 plus 1 plus 10, 70 seconds here. So instead of 7 minutes, 10 seconds, I have rewritten this as 6 minutes and 70 seconds. And now we're going to do the subtraction. We're going to have 70 take away 47. So 7 from 0 we have to borrow, so this is 10, take away 7 is 3, 6 take away 4, 2, we have 23 seconds. And then 6 take away 3, 3, so the answer that you'll see, 3 minutes, 23 seconds. Okay, so it's similar to the subtraction that you worked with integers. If you do not have enough here, you borrow from this column. But here, instead of having 1 10 and you change it to 10 ones, you have 1 minute and you change it to 60 seconds. Not 10 seconds, but 60 seconds. You add it to the 10 and you get 70 and you do your subtraction in that way. Okay, let's try a problem involving weight. You might have a problem 4 pounds, 2 ounces, take away 2 pounds, 10 ounces. Okay, once again, starting on the right, we cannot take 10 from 2, so we'll have to borrow. Instead of 4 pounds, we'll make it 3 pounds, and we have an extra pound. And the extra pound can be rewritten as 16 ounces. Okay, so always keep track. We're borrowing now from the pounds column, but 1 pound is equal to 16 ounces. So 16 plus 2, we have here 18 ounces. So instead of 2 pounds, 10 ounces being subtracted from 4 pounds, 2 ounces, we have 2 pounds, 10 ounces being subtracted from 3 pounds, 18 ounces. And now we can do the subtraction directly. 18 take away 10 leaves us with 8. So 8 ounces, and 3 take away 2 leaves us with 1. 1 pound, 8 ounces for our answer. Okay, let's try a problem involving length. 5 feet, 10 inches, plus 3 feet, 9 inches. Okay, 10 plus 9, 19 inches. 5 plus 3, 8 feet. However, you probably would not find 8 feet, 9 inches as one of the choices, because 19 inches is over a foot. And therefore, we would rewrite 19 inches as 12 inches plus 7 inches. In other words, 19 inches is really 1 foot plus 7 inches. So instead of the 19 inches, I will rewrite that as 1 foot, 7 inches. And now we will see that our final answer is then 9 feet, 7 inches. It seems that in the addition problems, they generally involve having to transfer back. In other words, you wind up with, say, more inches than you would have in a foot or more ounces than you would have in a pound, and you have to transform back to the units the other way. And in subtraction problems, you have to also show that you can deal between the different types of units, but usually to borrow so that you have a large enough number up here to do the subtraction. So in one way or another, you will be required to know those conversions that I gave you in the beginning of the tape, involving pounds and ounces, inches and feet, and minutes, seconds, and hours. Okay, let's try another possible example that you might have on this type of problem. It could be a problem involving words. Don't freak out if you see a problem with words. Just try to understand what's going on. The question could be written like this. A movie began at 4:20 p.m. and ended at 6:05 p.m. How long did it last? Began at 4:20 p.m. and ended at 6:05 p.m. Okay, so what we really want to do is from 6 hours, 5 minutes, which is the 6:05 when it ended, we want to subtract the time it started, 4 hours, 20 minutes, and the difference will be the length of the movie. 6:05, I wrote as 6 hours, 5 minutes. That's when it ended. It started at 4:20, 4 hours, 20 minutes. We will subtract to find the length of the movie. Okay, 20 minutes from 5 minutes. We can't do that directly, so we'll have to borrow. Change the 6 to 5 hours. We have now an extra hour. An hour is, of course, 60 minutes. So we have 60 plus 5, or 65 minutes. So instead of 6 hours and 5 minutes, we're thinking of it as 5 hours and 65 minutes. Okay, now 65 take away 20 is 45. So 45 minutes, 5 take away 4, 1 hour, 45 minutes. So the movie lasted 1 hour and 45 minutes. Usually on the CUNY assessment test, you are asked to add and subtract fractions that have different denominators. Let's go over some work with fractions before we actually get into this. Okay, I assume you're all aware of the fact that a fraction is a number that can be written as a quotient of two integers, one whole number over the other. We assume that the number on the bottom is not 0. The number on top we call the numerator, and the number on the denominator, and number on the bottom we call the denominator. Okay, so for example, something like 3/4 is a fraction. Now, if the numerator is less than the denominator, if P is less than Q, we call it a proper fraction. Okay, let me just remind you of this symbol. The symbols for less than and greater than before we get into this. I can write 3 is less than 4. This symbol is less than. And I would write 4 is greater than 3. So that's the symbol for less than, and that's the symbol for greater than. Okay, so if P is less than Q, if the number on the top is less than the number on the bottom, we call it a proper fraction. If P is greater than Q, okay, it's called an improper fraction. But still a fraction. So 3/4 would be a proper fraction, and for example, 7/3 would be an improper fraction. 3/4 is an example of a proper fraction, 7/3 an example of an improper fraction. For our work with fractions, the most important thing to remember is what we could call the fundamental principle of fractions. Okay, a fraction P over Q is equivalent to a fraction K times P over K times Q, where K is not 0. We automatically assume that Q is not 0. We never speak of a fraction where the denominator is 0. Okay, but I'm writing this. What I'm saying here basically is that if you have a fraction, and if you multiply the top and the bottom of the fraction by the same non-zero number, in this case K, you will get an equivalent fraction. On the other hand, if you start with a fraction like this and you divide the top and the bottom by the same non-zero constant k, you will also get an equivalent fraction. So it's legitimate to multiply the top and bottom of a fraction by the same number and get an equivalent fraction, or to divide the top and bottom of a fraction by the same number and get an equivalent fraction. And we'll be needing this in a few moments. Now, the important thing to remember when adding and subtracting fractions is they must have the same denominator, or you cannot proceed. Okay? If they do have the same denominator, you simply combine numerators and place them over the common denominator. For example, if I have 1/5 plus 2/5. Okay, they have the same denominator, same number on the bottom, 5. You simply combine the numerators, 1 plus 2, that's 3. And put it over the common denominator for an answer of 3/5. Similarly, if you have 7/8 take away 3/8, you combine the numerators, 7 take away 3, that's 4, and put it over the common denominator of 8. By the way, the answer 4/8 might not appear on the assessment test as one of the possibilities. They might write it in equivalent form of 1/2. Remember, using the fundamental principle of fractions, you can divide top and bottom by the same non-zero number. So if we divide top and bottom by 4, 4 divided by 4 is 1, 8 divided by 4 is 2. Or if you want to think of it this way, 4/8 could be thought of as 4 times 1 over 4 times 2. So it exactly matches what we had over here. 4 times 1 over 4 times 2. That's 4/8. Can be written, of course, as 1/2 because we can cancel, in this case, the k's. Here we have the 4's. 4 times 1 over 4 times 2. We cancel the 4's and we get 1/2. So 4/8 might appear as a possible answer, but in this case, you might get 1/2. And you'd have to know that 4/8 is equivalent to 1/2 using the fundamental principle of fractions. Okay, now this is if the fractions have the same denominator to start with. If not, what you must do is to first rewrite each fraction as an equivalent fraction where all the equivalent fractions have the same denominator. Let's try an example. Let's say we want to add 2/5 plus 3/7. Okay? They do not have the same denominator. Okay? You cannot simply add up the tops and add up the bottoms. Chances are you will see the wrong answer 5/12 on the assessment test as one of the possibilities, hoping that you'll fall into that trap. But you know that you cannot add fractions unless they have the same denominator. However, these two don't. What we're going to do is to try to rewrite 2/5 and 3/7 as equivalent fractions having the same denominator. Now, what denominator? We are looking for the lowest common denominator, the smallest number, so that 5 and 7 are factors of this number. That is, 5 and 7 divide evenly into this number. Very often, the product of the two numbers will work, and in this case, that happens to be the lowest common denominator. That is 35. In other words, I am looking to write each of these fractions as an equivalent fraction having the same denominator of 35. Now, why did I pick 35? Because 5 and 7 both go evenly into 35. Now, according to the fundamental principle of fractions, I can get an equivalent fraction if I multiply the top and bottom by the same non-zero number. Now, to change 5 to 35, I have to multiply by 7. If I multiply by 7 on the bottom, I would want to multiply by 7 on the top. In other words, 2/5 is clearly equivalent to a fraction, which is 7 times 2 over 7 times 5. But 7 times 2 is 14. 7 times 5 is 35. So 2/5 is equivalent to 14/35. 2/5, it's equivalent to 7 times 2 over 7 times 5, or 14/35. Similarly, working with 3/7, we'd like to change that into an equivalent fraction with denominator 35. And we say, well, what do you have to do to the 7 to make it into a 35? You would have to multiply the denominator by 5. Well, if you're going to multiply the denominator by 5, you have to multiply the numerator by 5 to have an equivalent fraction. Okay, so 3/7 is equivalent to 5 times 3 over 5 times 7, or 15 over 35. So we can rewrite 2/5 as 14 over 35 and rewrite 3/7 as 15 over 35. And now we're in the same position that we were on top. In other words, we want to add two fractions that have the same denominator. So we will combine the numerators, 14 plus 15. If you can't do that in your head, you can go over and actually do it. 14 and 50. That's 29, and we get 29 over 35 as the answer to this problem. Remember, to add the fractions, they must have the same denominator. So we will first find fractions equivalent to these that have the same denominator. We picked 35 as the lowest common denominator, and we asked ourselves in each case, what did we have to do to the denominator to get 35? And whatever we had to do to the denominator, we had to do to the numerator as well, according to the fundamental principle of fractions. So we had 2/5, and we wanted to change it into some number of 35ths. We said the denominator would be 35 if we multiplied it by 7, so we had to multiply the numerator by 7 as well. With 3/7, we said the denominator would be 35 if we multiplied by 5, so we had to multiply the numerator by 5 as well. And then we got equivalent fractions with denominators that are the same, and then we added the numerators and put them over the common denominator. Okay, let's try another problem. 3/4 plus 5/6. First thing we have to do is to find fractions that are equivalent to 3/4 and 5/6 that have the same denominator. Now, if you use the product of the denominators 24, nothing terrible happens. And in fact, I'll do it for you a little later on, except you do have to reduce at the end. However, the lowest common denominator in this case happens to be 12. The smallest number that 4 and 6 are both factors of is 12. So we're going to try to turn these into equivalent fractions having the same denominator of 12. Now, we have 3/4. We want to change it into a certain number of 12s. We say to ourselves, what do we have to do to 4 to get 12? We have to multiply the denominator by 3, so we have to multiply the numerator by 3 as well. Because we're multiplying the denominator by 3 and the numerator by 3 as well. Similarly, we say, what do you have to do to 6 to get 12? You have to multiply the 6 by 2. Well, if you're going to multiply the bottom by 2 to get an equivalent fraction, you have to multiply the top by 2 as well. So we would get 10/12. So 3/4 is equivalent to 9/12. 5/6 is equivalent to 10/12. Now that they have the same denominator, we can add 9/12 plus 10/12 gives us 19/12 as the answer to the problem. Now, if you happen to see that 12 is the lowest common denominator, fine. If not, it's not terrible if you use the product of the denominators. Let's see what would happen in that case. It's not the preferred way, but we wanted to add 3/4 plus 5/6. If instead we changed into 24ths, which was the product of the denominators, okay, we'd have to multiply 4 by 6 to get 24, so we'd have to multiply 3 by 6. So it's equivalent to 18/24. Here we'd have to multiply 6 by 4, so we'd have to multiply the numerator also by 4, so it's 20/24. So you could write this as 18/24 plus 20/24, which would be 38/24. Now the only problem is that 38/24 would not be one of the choices on the assessment test. So what you would have to then do is to say, look, 38 is really 2 times 19, and 24 is really 2 times 12. And of course you can divide top and bottom by 2, cancel the 2's, and you get the same answer that we got before, 19/12. Okay, a little more work in that you had to reduce at the end. Okay, but that actually, in any case, you might wind up with having to reduce to get one of the answers on the assessment test. If you happen to find the lowest common denominator right away, fine, and if not, don't get upset. You can use the product of the denominators. It's better than not doing the problem. Okay, let's try another problem. This time we'll subtract fractions. And of course, you should pay special attention. Okay, make sure that if it's an addition problem, you're adding. If it's a subtraction problem, you're subtracting. Okay, it's silly to lose points for nonsense. This is a subtraction problem. Okay, we're going to combine over the lowest common denominator. In this case, the smallest number that 20 and 6 both go evenly into is 60. So we want to write this. You can do them separately the way we did in the other problems, or you can just say I'm going to build fractions equivalent to these having the denominator 60. Now, 20 has to be multiplied by 3 to get 60, so 17 has to be multiplied by 3, and when you multiply 17 by 3, you would get 51. 6 has to be multiplied by 10 to get 60, so 1 has to be multiplied by 10 to get 10. In other words, 1 6 is equivalent to 10 60ths, and 17 20ths is equivalent to 51 60ths. In this case, we multiplied top and bottom by 10. In this case, we multiplied top and bottom by 3. 17 times 3 is 51. Now we have the same denominator, so we combine the numerators. 51 take away 10, that's 41 over 60 for our final answer. Okay, we've learned how to add and subtract fractions. We now move on to multiplication and division of fractions, which often appears on the exam. When you want to multiply two fractions, let's say a over b times c over d, all you do is you multiply the numerators, get a times c, and put it over the product of the denominators, b times d. So just multiply the tops and divide by the product of the bottoms. And then you may have to reduce to lowest terms. Actually, reducing to lowest terms can be done earlier in the problem or at the very end, and we'll see that in a moment. Let's try an example. 2/5 times 4/9. You multiply the tops, 2 times 4, that gives us 8. Divide by the product of the bottoms, 5 times 9, 45. So 8 divided by 45, or 8/45. What about 3/5 times 10 over 21? Well, you can multiply the tops, giving us 3 times 10, 30, and divide by the product of the bottoms, 5 times 21, which is 105. However, when it comes time to looking for that answer on the assessment test, you will not find 30 over 105 because it's not reduced to lowest terms. So the question is, how do we reduce it? Now, you can just take it a little bit at a time. We know that, for example, both of these numbers are divisible by 5. So we could say 30 is really 5 times 6, and 105 is, of course, 5 times 21, because that's where it came from, which just may make us think that obviously this is not the most efficient way of doing this, because first we multiplied and then we're factoring it again, and we're going to discuss a better way of doing it in a moment. Okay, 30 is 5 times 6, 105 is 5 times 21, so we can cancel the 5s and write this as 6 over 21. However, 6 over 21 will also not be one of the choices on the assessment test, and that's because 6 is really 3 times 2, and 21 is really 3 times 7, and you can cancel the 3's, giving us a final answer of 2 7s, and that most likely would be the answer that you would have as one of the choices on the exam. So the answer to this multiplication is 2 7s. Now there actually is a better way of doing this. Let me rewrite the problem right on top. 3 over 5 times 10 over 21. I did mention earlier that this does not seem like a very efficient way of doing the problem. Okay, now we know we're going to multiply the numerators and divide by the product of the denominators. However, okay, everything in the numerator becomes part of this new numerator, and these denominators join together to become part of this denominator, and we can reduce. Okay, and we have this one big fraction, and we can, of course, cancel out common factors in this case. So we can divide, for example, top and bottom by 3. 3 divided by 3 gives us 1. 21 divided by 3 gives us 7. 5 divided by 5 gives us 1. 10 divided by 5 gives us 2. Now, in this case, you get 1 times 2 over 1 times 7, and you get the same answer, 2 sevenths, and it seems a lot less painful. Okay, you don't have to first do the multiplication and then do all the canceling. Okay, remember, anything in any of the numerators can cancel anything in any of the denominators. Any factor in the numerator can cancel, in either of the numerators, can cancel any factor in either of the denominators, because they're actually, all the numerators combine here, and the denominators combine there. So we divided top and bottom by 3 here, and here we divided top and bottom by 5 to get 2 sevenths. Okay. Multiplication of fractions was handled by simply multiplying the numerators and dividing by the product of the denominators. Division of fraction is handled slightly differently. When you have one fraction divided by another fraction, it'll probably be written like this. What we do is we take the first fraction and we invert the second fraction and multiply. So a over b divided by c over d is rewritten as a over b times d over c. In other words, you invert the second fraction and you multiply. You invert the divisor and multiply, giving us a times d over b times c. So it reduces to a multiplication problem. You invert the second fraction, the divisor, and you multiply. A times d divided by b times c. Let's try some examples. Nine tenths divided by 3/4. Okay, the rule is to invert the second fraction and multiply. Okay, so we have 9 times 4 over 10 times 3. Now you can write this as 36 over 30 and reduce afterwards, or you can say right now, look, before I multiply, let me divide top and bottom by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. For the 4 tenths, 4 and the 10 there, I can't divide by 4, but I can divide top and bottom by 2. 4 divided by 2 gives me 2. 10 divided by 2 gives me 5. So I get an answer of 3 times 2, 6 over 5 times 1. Remember that if you did the multiplication straight, you would have gotten 36 over 30, okay, which is equivalent to that if you divide top and bottom by 6. 36 divided by 6, 30 divided by 6. So either way, if you prefer to do it this way, fine. The important thing here is to get the right answer. You can multiply first and then divide, or do your simplification first and then multiply. Either way, the answer that you would probably have to check on the assessment test would be 6/5. Okay, so we know now how to multiply, divide, add, and subtract fractions. Very often, these questions on the assessment test are not given in terms of straight fractions like this, either proper or improper, but rather they're written as mixed numbers. Okay, a mixed number is a number of the form, let's say, 5 4.5, which is part whole number and part fraction. Okay, we have an integer and a fraction. This is really 5 plus 1/2. Now 5 could really be thought of as 5 over 1. So we can add these fractions together by combining over the common denominator, which would be 2. 1/2 we leave alone. 5 over 1 is equivalent to 10 over 2. In other words, you can multiply top and bottom by 2. 5 over 1 is equivalent to 10 over 2. Now when you have 10 halves plus 1/2, okay, that's 5 and 1/2. 10 halves plus 1/2, that is 11 halves. And now we have an improper fraction, which is equivalent to this mixed number. When your problem on the assessment test involves mixed numbers, the way to handle it is to first change the mixed number into an equivalent improper fraction, and then to proceed by the techniques that I've already shown you for addition, subtraction, multiplication, and division of fractions. The rules that I gave you already are good for fractions, whether they're proper or improper. However, you cannot deal with the mixed numbers directly. You must first turn them into fractions, in this case, for a final answer of 7/12. I just want to do a multiplication and a division with you as well on the mixed numbers, and that will bring us to the end of this tape. Okay, how about 2 1/3 times 1 3/4? The same example numbers that we used before. Here we were subtracting, and of course you should pay attention to what the arithmetic operation is. This was 2 1/3, take away 1 3/4. This is 2 1/3 times 1 3/4. Once again, we have to turn these into improper fractions. We've already done that. 2 times 3 is 6 plus 1. This is 7/3 times 1 times 4, 4 plus 3, 7/4. We now multiply these fractions by multiplying the numerators and dividing by the product of the denominators. We get 49/12 as an answer. 49/12 might be the answer that you see on the test, or it might be written as a mixed number. 12 into 49 goes 4 times. 4 times 12 is 48. We subtract with a remainder of 1. So it can be written as 4 plus 1/12. So the answer might be either 49/12 or 4 1/12. Okay, how about now 2 1/3 divided by 1 3/4? This would be 7/3 divided by 7/4. These are the same numbers that we were using before, of course. But now it's 7/3 divided by 7/4, which means to finish this off, you would have to invert and multiply by 4/7. And that would give us, now you can multiply and get 28 over 21, but that does seem silly because we can certainly cancel the 7s and get a final answer of 4/3. Okay, let's just try 2 quick division problems, and that'll bring us to the end of the tape. 4 divided by 2 1/2 and 4 1/2 divided by 2. I just want to make sure that you know how to handle them if they're not both mixed numbers. Only one of them is a mixed number. 4 divided by 2 1/2. This would be 4 divided by 5 halves. 2 times 2, 4 plus 1, 5, which is 4 times 2/5. You invert and multiply, so you're multiplying by 2/5. And that gives us an answer. Remember, 4 is really 4 over 1. So that gives us an answer of 8/5, or possibly it might be written as 1 3/5, which is equivalent to 8/5. Similarly, over here, we have 4 1/2, which is 9/2 divided by 2. 9/2 times, now inverting, this is really 2/1. So when we invert and multiply, we are now multiplying by 1/2, giving us a final answer of 9/4. And the answer on the test might be either 9/4 or may be written as 2 1/4. Okay, you could leave it either way. Check to see which one is on the exam. Okay, remember you're inverting and multiplying. Okay, here when you have an integer divisor, it's 2 is really 2/1, and you invert and multiply, you get the 1/2. And that brings us to the end of this videotape. If you have any questions, please consult with one of the tutors in the math lab.